Hey everyone, what's up? In the last video we mostly completed our chessboard part, so it looks like this, and now we're going to continue by adding a new player class that makes random moves so that we can start building our game loop. So for example, we'll choose our one of our pieces, make a move, and the random player will respond by making a random move, and then we can make another move, and so on and so forth. So we will be able to test our, for example, legal move computation, the turn-based system, and our listeners, and some other things as well. So this initial primitive algorithm that makes random moves will be used as a tester, kind of. So we are of course going to build a much more sophisticated AI later on, but we'll use this random player for a while. So let's go ahead and look at our chess player class that we have created earlier. And let me remind you that this class takes in a board object and the side argument here, and makes, for example, it has a make move method and compute all legal moves method that will be shared among all the chess players that we are going to create. So this will make a move physically, take in a chess move parameter and make a move accordingly, and this method will get all the legal moves that a player can make. The main difference will take place inside this decide move method. So this base class will be going to use by the user. So the human will be represented with the base chess player class. So its decide move method is empty. The one who has to decide a move will be the human or the user. But when it comes to the artificial intelligence players, this method will be overridden, and how successful an artificial intelligence player will be determined by this method. So let's go ahead and create a new class that extends this class. Let's name it random player, and extends chess player. So add a constructor that takes the required arguments, board and side, and let's add our new overridden method, override public chess move decide move. Alright, so what we are going to do inside this decide move method is, firstly, we're going to do two things. First of all, we are going to pick a piece randomly. So we have, at any point of the game, we are controlling some number of pieces. For example, I'm controlling 10 pieces at the moment. I have to get a number from 0 to 9 to randomly select a piece. So in order to ensure that I'm randomly selecting a piece, I'm going to need a random object, and let's initialize this inside our constructor, new random, and let's get a piece index. So int piece index, or random piece index, random next int. So before that, actually, we have to get a reference to our current pieces. Pieces is equal to board get army. So let me. Okay, this is private, so I can't access that. Let's make this protected, and also let's make the side protected also. So the getArmy method takes in a side argument. The side is side, of course, and get alive pieces. All right. So the next int will be will take an argument of the number of pieces. So pieces size. All right, I changed it to public or protected. I should be able to access that. Okay, I didn't save the changes. Alright, so I have my random index. So now I can get a reference to my random piece. Random piece is pieces get random piece index. So I have my random piece now. What I'm going to do next is get the legal moves that this piece can make. So list square legal moves is equal to random piece compute legal moves, and that's it. The first step is to get the random piece, and the next step, actually it's not completed. The next step is getting computing the legal moves and selecting one also randomly. But before selecting a move randomly among these legal moves, we have to ensure that there is at least one legal move. So this list could be empty because, for example, if my pawn is blocked by another piece, I have 10 pieces, but one of my pieces can't move anywhere. So actually I have to repeat that multiple times. I may have to repeat that if the piece I selected contains no legal moves, has no legal moves. So I can ensure this by using a do while loop. So inside this block, I'm going to do everything I did here. And I'm going to check if my legal moves contains at least one move. So if the legal moves are empty, I'm going to repeat that once more. So what does that say? Cannot be resolved. Okay, actually I have to move the declaration out of the loop and delete that. Okay, so when I come to this line, I have ensured that my random piece can make at least one move. So now I have to make a decision about selecting one of those moves. So let's get an index of the moves this time. So random move index is equal to random next int legal moves size. and then I'm going to get the square reference of that move. Target square is equal to legal moves get random move index. Okay, so now I can safely return a new chess move object. Let's look at the constructor. It takes an initial square, target square, and target piece. So the initial square is random piece get square. The target square is target square. And the target piece is target square get piece. So of course this target square can be null if there aren't any pieces on the square that we are going to move. So cannot be resolved to a variable. So I have to move this out of the loop as well. Oh, actually I forgot the parentheses. Alright, so our decide move method is complete now. So let's add also a toString method. String public string return random player. We might need that to display which player we face. So when I create another player, I have to display another string. This will help me inside the game to see which player I'm facing. So to be complete, let's add a toString method to our base class as well. Public string return. Let's name that simply user. Alright, okay, before wrapping this up, there's one last thing that I want to do, and this concerns our chess room class here. So we have created earlier this class, and inside it there are two army objects and a board object. We are creating all those here inside the constructor, and we are creating our initial pieces and adding those pieces to corresponding armies, and also we are referencing or we are associating those pieces in our board. The only thing that's missing here is our player objects. So now that we have created a random player class and we already have our chess player class, we can now add two players inside our chess room. So let's go ahead and create a new field, private final. So let's make a map so that we can access our players by their sides. Side chess player players. And we have to export the player package and import it from our application plugin. Alright, so since this is a final field, we have to initialize our players inside the constructor. So players is new hash map side chess player, and we're going to add two players inside this map. So players put side white new chess player. The white army will be controlled by the user, and the black army will be controlled by the AI. So let's make that black. The chess player will take a board and side argument, side white, and this will be black. So let's also add a getter for our players, like this getBoard class, getBoard method. So chess player, get player, and now the map structure will help us to identify our players or select our players by their side attribute. So I'm going to say get me the white player or get me the black player. So return players get side. So that's all for this video. Probably in the following video, problems detected, missing constraint. Okay, so actually I think we forgot to add this plugin to our features. So let's go ahead and check that. So as you see here, there's a included plugins tab that our application needs. So there's our application plugin and the chess core plugin, but we didn't add our chess player plugin. That's because we are getting this error. So let's add player plugin, and we have to launch our application from the product once we make a change like this. So launch an Eclipse application. Alright, so the error went away, as you see. So I was saying in the following video, probably, we are going to add a listener that listens. So we are going to create 64 listeners, one for each square, that listens our mouse clicks and lets us select a piece, and that will allow us to move that piece. And then our random player will make a move as a response, and the turn will come back to us and we'll make another move, so that we are going to test our capabilities such as making a move, capturing a piece, and so forth. So see you in the next video.